Moving to who we are, what we are. We are multi-cloud for you. Fifth IR. Fifth IR stands for Fifth Industrial Revolution. We have hundreds and thousands of the strong community of technologists from all over the world. We deal with technical sessions, consultations on multi-cloud strategy, data science and AI, blockchain, and extreme engineering. We help technologists to share their learning and get opportunities through our partners worldwide. We are growing. Yes, we are growing. We have offered 239 jobs through our platform, and we have 9 events, upcoming events in our platform, and we have conducted 1,000+ sessions through our platform, that is Fifth IR, and we have 360 speakers associated with our platform, and we have delivered 8,000+ certificates through our platform, and we have totally 25,000+ members present in our platform. And moving to, we have different mastermind days, MEPs associated with our platform. These are the few MEPs and mastermind days associated with our platform. You can see more about us in www.fifthir.com. And we are the academic partner of Alibaba Cloud. These are the few certification courses we have done in line with Alibaba Cloud, and you can get certificate directly from Alibaba Cloud by using this link which is provided over here. How we help you? We help you building knowledge, digital presence, and help you in odd hours when you are looking for jobs through our community. All this you can access through a single link, that is www.fifthir.com. As a part of our community, we are going to provide a free level 1 certificate to all the participants, and you can download the certificate by providing the secret code, which will be provided to you at the end of the session. This is a sample certificate which you can download from the download after providing the secret code. And moving to the speaker of the day, it is Mageshwara Kumar. He is an Alibaba Cloud MVP and AWS community builder. He has associated with different roles in the organization, such as senior consultant, technology specialist, and project team lead. He has got a couple of certification. He has got a couple of certification from AWS. He is a AWS certified solution architect associate as well as professional. He has got a certificate from Alibaba Cloud, that is Alibaba Cloud Associate certification, and then he's a Microsoft certified Azure data engineer, and he's also a Sun certified Java programmer. You can see more about him in the given LinkedIn profile. And now over to Mageshwara Kumar.
Thank you, Gavaskar. Thanks for the introduction. So let me share my screen. So yeah, my screen is visible, Gavaskar?
Yes.
Right. Thanks all for joining my session in this. I think first of all, good evening, good afternoon, good morning. I think different participants from different parts of the world. So this is going to be a tech talk on Amazon Redshift. So I will explain this in layman terms. So I think if you are not part of data, it will fetch you some interest towards the data part, and it will give you some quick high level overview and insight about Amazon Redshift. So moving to the deck, the list of topics what we are going to discuss in today's webinar is like introduction to Amazon Redshift and architecture of Amazon Redshift environment, Redshift component and how it works, data warehousing using Amazon Redshift actually, and benefits of Amazon Redshift, comparison of cloud and traditional data warehouses, pricing, market adoption in similar products, and other things actually. Okay, sorry for that slide. So moving to the next slide. Introduction to Amazon Redshift. So this is what I want to discuss as an introduction. Before entering into the introduction to Amazon Redshift, I want to quickly discuss about what is a data warehouse. Hope in this audience, actually, if someone is not from data warehousing background, it will give them the little bit insight about what is a data warehouse. So data warehouse is nothing but a collection of data for a predefined for a business purpose. For example, if a product is selling in an online store or wherever it is, like, they will collect the data. For example, if a particular product, what is the saleability of the particular product in a particular year, in particular month, and all those things, they will store the data in rdbms actually, and a small collection of data which is having a business insight. So this is called a collection of data with business insight. It is called as a data warehouse. The smallest unit is called as a data mart actually. Okay, so smallest unit is like a very small unit. Different data marts will constitute a big data warehouse. Okay, so in this Amazon Redshift is a cloud data warehouse actually. So before the evolution of cloud, we have on-prem data warehousing tools, like different types of tools like uh, Informatica, then data stage, pentaho, open source, ab initio, and all these things. Moving into the cloud, the different data warehouse actually, it is called as like in Amazon Redshift. So this is what we are going to discuss in today's tech talk. So hope you had a quick insight about this. And coming into the definition of Redshift, it is a fully managed petabyte scale data warehouse service in the cloud actually. So you can store data onto the scale of a petabyte actually, because in on-prem you cannot store petabyte of data, which is an advantage in the cloud data warehouse like it is Amazon Redshift. So you can start with a few hundred gigabytes of data and scale up to petabytes and even more than a petabyte actually. This is a good advantage in Amazon Redshift. This enables you to use your data to acquire new insights for your business and customers. So, using this data warehouse, you can constitute a data warehouse using a ETL tool. Okay, pulling data from different sources, transforming the data, and loading the data into a final data warehouse. Using the reporting tool, you can able to create a dashboards, and you can understand. You can make the business owners understand your customers. That is why it is saying it is to acquire new insights for your business and customers. Okay, so this product is released in October 2012 actually. So Amazon Redshift is came into the market in 2012. AWS Amazon Redshift AWS Redshift is a product built by Amazon Web Services. It is used for large scale data storage and analysis. What is the purpose? Means it is used for large scale data storage, to store large scale of data, and for used for analysis. Okay, and is used to perform large database migrations also. We can able to perform in this thing. So this is a brief introduction, and the customers use Amazon Redshift data RDS databases primarily for online OLTP process. Okay, while Amazon Redshift is primarily used for reporting and analytics. This is the difference between RDS, relational database system, and the Redshift. For Redshift, it is used for reporting, end reporting, to depict your data, final representation of your data to the business customers, and how to analyze the data further actually. So this is the primary use of Amazon Redshift. So let me move on to the next slide. So I will first, this is the pictorial representation of a what is the client it's a simple architecture of a AWS Redshift environment here. You can see the client applications, you can see the JDBC, ODBC, you can see the leader node, computer node, node slices. And this is one or two nodes constitutes a cluster actually. Okay, so you can see like leader node is there. I will explain the features of the in the coming slide. So this typical architecture consists of a client application, a leader node, a computer node, a node slice. So this is whole together. It's the entire thing is called as an AWS Redshift environment. So this is how the picture looks like. Wherever you go for the architecture diagram, you will get this. Okay. Let me go to the next slide. So here, let us discuss in detail actually what is Redshift, what are its components, and how it works. For example, in a cloud environment, you know the VPC, virtual private cloud actually, so that like In the previous diagram, you must have seen that the client application somewhere, right? Here, the client application is SQL client BI tool. Okay, so in the Temple architecture and all, the client used to make a request to the node. Actually, node is like a server. Actually, it can constitute the cluster is constituted called as a database also. So one or two clusters is having a database also. So it will have the leader node. The client will make a request through JDBC ODBC calls to the leader node actually. Okay, and the leader node will pass this thing to the computer node, compute node actually, not computer node, compute node actually. From there, it will go to the node slices. In the previous diagram, if you see the node slices are there actually. So it all distributed thing actually. So let us see client applications. You know that it is simple. Whichever client, it's a client which is used for making a request, web client or any client actually. So cluster, what is a cluster means you have a leader node, a compute nodes, and node slices. So all these together constitutes a simple cluster. So, okay, so let us discuss what is a leader node actually, why it is used for. The leader node will transmit the SQL query plan or request to the compute nodes. So it is a simple SQL endpoint. What it does has is it stores the metadata. Metadata is data for data, and it optimizes the query plan. If the query is coming from the client, it optimizes the query plan and and coordinates the query execution. So it will get the request, pass it on to the compute nodes, and from compute nodes it will go to the node slices, and from the node slices it will go to, again the request will, they process the data, it will come to the compute node. From compute node it will come to the leader node, and from leader node it will be passed on to the through JDBC ODBC calls to the client back. The result is published back actually. Okay, so what are compute? You can see the compute nodes, am I right? So compute nodes are like they have the columnar storage actually. In typical RDBMS, you must be heard about the row storage, am I right? Here, it is columnar storage. Okay, while discussing the benefits, like if you see in RDBMS and all, like you have the one data, for example, employee name, employee number, salary, or department name actually. Okay, so employee number is one, employee name is Suresh, employee department is like IT. So a couple of data is like that. Okay, okay, they will store the entire thing is number, name, and department will be stored as a single block in the row storage. Okay, I am explaining the difference between columnar storage and row storage. Okay, in the row storage, the first number, employee name, employee salary, and department will be stored as a one block. But in columnar storage, there are different number of employee numbers will be there, am I right? There are different number of employee names will be there, am I right? So the entire employee number will be stored as one block. Instead of all the instead of all the fields in one block, we are storing the same type of data. Employee numbers, there are multiple number of employees, am I right? Number, employee number one, employee number two, employee number three. All these records will be stored in a single block as a columnar storage actually. By using this, what is the performances? It will have better performance actually. Okay, so if you want to retrieve the data, you can retrieve the similar type of data. Input IO operations are very fast. You can retrieve the data very quickly. So this is the one best advantage of columnar storage. Okay, second thing is parallel distribution of all queries, loads, backups, and restores. What is parallel distribution? If you see in this previous picture, in order to explain you further more clearly, for example, client application makes a request using the JDBC to the leader node. The leader node will transmit the query to the computer node, actually, compute node. In the compute node, in further, it is divided into node slices. Okay, here. The compute node receives the query plan from leader node and pass it on to the node slices. All the node slices will parallelly process the data. Everybody will be having the equal memory, size, and everything. So parallelly, the processing will be distributed. All the parallel processing will be done actually. So the performance is 10 times faster than the on-prem cloud data warehouse actually. On-prem data warehouse instead of the cloud data warehouse. So in this picture, that's what they want to say, parallel distribution. If you want to distribute the load parallelly, then this using parallel distribution of the load, it will coming to the compute node. From compute node, it will go to the node slices. it will process the data, and the final result will be passed on back to the compute node, and from compute node it will pass the thing to the leader node. From leader node it will coordinate the query execution and it pass it on to the client. The request will be the responded to the client using the JDBC ODBC connection. So this is what the simple distribution actually. So here you can see here, and there are three types of nodes actually, compute nodes actually. You can say dense storage. Dense storage, it is used for if there is large number of storage optimized actually. Storage, if a large number of storage is required, then we can go for the dense storage node. It is called like a hard disk drive. And if you want to use large number of compute operations actually, then you can go for solid state drive, SSD drive actually. It is dense compute. So these are the two basic differences between the two nodes actually. And in the recent they are using RA3. This is the recent it is used now. RA3 is the combination of both dense and dense compute actually. Okay, so this is what actually the compute nodes will having. Another good advantage is automatic caching. Best advantage is automatic caching. Okay, automatic caching in the sense like it will cache the results in the cache. So again the same type of queries executed, what they will do is like it will fetch the data from the cache and return it to the end result to the client actually. And concurrency scaling, it will say scale concurrently. So if I want to explain the differences here, I want to mention the differences of the cloud data warehouse. Here is, it is very difficult to manage the traditional on-prem data warehouse, but in the case of cloud data warehouse, it is easy to manage actually. Okay, so means like if you want to buy, for example, one compute nodes actually, cost will be involved actually, lot of cost. If you want to scale up, it is not possible in the traditional. Here in the cloud, as the cloud future, you can scale depending upon your need actually. Okay, so you can scale up to a number of compute nodes, and based if you want to scale down, you can scale it down also actually. So this is one good advantage actually. This is what concurrency scaling. Okay, so that's one good advantage. What another advantage is spiraling cost actually. If you want to use the traditional data warehouse, lot of cost is involved actually. Okay, to buy the machine, to buy the things, everything. But here in cloud data warehouse, within button of clicks, it will ask you to configure how many number of leader nodes you want to configure, what are the things actually, or whether it is HD dense storage or dense compute. So after configuring everything within a button click, you can configure a cluster actually. Okay, this is the difference between these things and cloud data warehouse and traditional data warehouse. Okay, so apart from that, another main advantage is like see, you can see in this picture you have the Amazon S3 MA, right? DynamoDB. Amazon S3 is another source actually. You can say
Mahesh
uh,
Kumar, Mahesh
yeah.
Kumar, I think your screen is not shared. Now it is okay. Okay. Okay.
Okay.
Yeah.
Okay. Sorry. Is it visible now?
Yeah. You can
Yeah.
share.
Sorry. Yeah. So what I am trying to say is like here in this picture, sorry, the same picture only I want to say it actually. Okay. So the next slide without going there. Here S3 you can see actually. Okay. Below you can see below the node slices. If you want to transfer data from S3, can be considered as a data lake actually. Data lake is nothing but it consists of both structured and semi-structured data in different type of formats, CSV, JSON, PARQ, all type of formats. The data will be present in the S3, which is a data lake. Okay, so if you want to load the data from S3 to data warehouse to the Redshift, it is a ETL process actually. Okay, you want to fetch the data from S3, transfer to load the data into the data warehouse. For this, we are using a thing called Amazon Redshift Spectrum. Okay, it is called Amazon Redshift Spectrum, which is used to query the data from the data lake and put the data in the put the data in back put the data in the Redshift. Okay, so Amazon Redshift is nothing but, since it is like component, I'm explaining all the component here actually. Okay, so Amazon Redshift Spectrum will query the data in S3 and put the data into the Redshift data warehouse. Okay, this is the use of Redshift Spectrum. So you must have heard about Athena and all, am I right? It is a query means like similarly here we have the Amazon Redshift Spectrum to query the data from S3 and load it into the Redshift. So the main purpose here, it is used for backup and recovery also actually. Okay, whatever data which is present in the Redshift data warehouse, a snapshot of the data will be maintained in the S3. So whenever something happens, if the data is somehow removed or something like that, it can be recovered from the Amazon S3. So it is backup and recovery is also a good feature here actually. Okay, and second thing, other thing which I want to say is like we can enable data encryption. Data encryption is enabled here during data at rest and also at transit. So this is the simple architecture which I explained you, including the S3. In between S3 and node slices will be have the Amazon Redshift Spectrum. Okay, so Redshift Spectrum, we query the data and put the data and load the data into Redshift from S3. Okay, so this is small the explanation about Redshift components and how it works. I am moving to the next slide. So in this slide, I want to show you this. This is how the cluster looks like actually. How the AWS Redshift console will look like is, you can see here actually, you can make connections, you can change connection, you can make a connection here, right hand side, you can see left hand side, you can see the schemas actually. Okay, here this is the query window where you can able to run the query, and the query results will be displayed in the screen actually. Okay, Redshift cluster will, this is the typical Redshift console. And before that, if you want to configure, it will ask you the number of cluster nodes, or how many nodes you want to configure and everything. So immediately the Redshift node will be configured actually. So this is how, this is the typical Redshift console which I want to show you guys actually. So how it looks like. Okay, let me move on to the next slide. What are the benefits of Amazon Redshift? Okay, I already discussed this with you. Anyway, I will. This is like columnar storage, which I explained to you, am I right? In my previous slide. So this is the one big advantage actually. Okay, in cloud data, which is especially in Amazon Redshift, and massive parallel processing. I told you, am I right? From leader node to compute node. From compute node is further subdivided into node slices. Once the leader node receives the query, it will pass it on to the compute node, and it will be parallelly distributed, and the result will be parallelly processed, and the result will be given to the compute. From compute node, it will given to the leader. From leader node, it will given to the client actually. So massive parallel processing. This is, and it is very fast actually. I told you, am I right? It is 10 times faster than the on-prem data warehouse actually. Okay, and it is very inexpensive. Why? Because you are paying for the pay as you go model here actually. What are, till the number of time you are using, till the time you are using, you have to pay for the time you are using, and after that you can means like you can remove the resources actually. No need to pay. But in traditional data warehouse, what will happen? You have to buy the, if you want to buy 10 machines, you have to bear the 10 machines cost. You want to bear the 10 machines resources, everything, storage, capacity, CPU, everything you have to pay for it, am I right? But if you come into cloud data warehouse, you pay for it for the time you are using. So it is very fast, and also it is cost wise, it is very inexpensive actually, compared to less expensive compared to the on-prem data actually, on-prem data warehouse. And the other point is faster query performance on data sets ranging in size from gigabytes to petabytes, concurrency scaling actually. I told you, am I right? You can store the data up to from GBs to petabytes actually. It is very big good advantage. It's enormous storage will be there. Okay, this is big difference between the traditional data warehouse and the cloud data warehouse. And there is a concept called zone maps, which reduces the amount of IO needed to perform queries actually, which is incorporated in Amazon Redshift. Okay, And also the another advantage is it can be integrated with machine learning for predicting patterns and everything, predicting the patterns of data and everything. So it can be integrated with machine learning. Okay, so and you don't have to worry about the security here. Why? The reason is the security is inbuilt within the Amazon Redshift. But for security in the traditional data warehouse, you have to worry about the security and everything actually. Okay, and efficient storage and high performance query processing. So efficient storage, I told you, means like which we have previously described seen. So good storage, we can efficiently manage the storage, and it is used for high performance query processing. Okay, and Amazon Redshift enforces these limits for database maximum of 60 user defined databases per cluster. Okay, 60 user defined database per cluster, you can have 60 user defined databases, maximum of 127 bytes for a database name actually. Okay, you can have a database name with the size of 127 data bytes actually. And Redshift is a PaaS service. Okay, Redshift is what? It's a platform as a service. Okay, so this is one good advantage actually. So you must have heard about IaaS, PaaS, SaaS, am I right? So Redshift is a PaaS actually. Okay, let's move on to the next slide. So what is like here you can see this the data warehouse using a Amazon Redshift. Here you see that I told you, am I right? It is like here you can see the S3 is simple storage, which it can be used as a source actually, data pipeline, EMR cluster. From that, I told you about while I was describing about Amazon Redshift Spectrum, am I right? The another thing is like if you want to query the S3 data, you can query it using the Amazon S3. And QuickSight is nothing but it is the final dashboard representation of the data actually. Okay, from Amazon Redshift, it is a data warehouse. From the data warehouse, you use the OLAP part to put the data in a graphical and user-defined format actually, dashboard, pie chart, the graphical format. You can see the data. That service is called in Amazon, is AWS is called as Amazon QuickSight. From Amazon, yeah, from QuickSight, we can able to see the data in Excel format and whichever format actually. So this is the simple diagram actually, which I want to make you to understand with this diagram. Yeah. Next slide.
Magesh,
Yeah.
the slide is not changed actually.
No, I changed it. I changed the slide. I think. Is it fine now? Hello, Gavaskar?
Yes, yes.
Yeah, sorry. I think some delay, something is there problem. Sorry for that inconvenience actually. Okay, so and I am moving to the next slide. Right. So this is deploying a data warehouse on AWS. If you want to deploy data on AWS, you know that the concept, am I right? Internet SQL client users, S3 bucket. You know the region availability. What is the region? What is the availability zone? In India, we have a region in Mumbai actually. So there might be different availability zones. Within that, we have multiple data centers actually. We have VPC, virtual private cloud. Within that, we have a Amazon Redshift. So this is how the pictorial representation of a how the Amazon Redshift is within an AWS actually. It's a reference architecture. Okay, right. Thank you. So here again we are comparing the cloud and traditional data warehouses here actually. Okay, cloud data warehouse and traditional data warehouses. Cloud data warehouse, what will happen? It is very easy to deploy and manage actually. Okay, instead of buying multiple resources, buying multiple machines, it is very easy to deploy, configure what is the number of within button clicks. It is easy to deploy and manage and go and with spin up the things actually. Okay, so this is possible in cloud data warehouse, which is very difficult to deploy and manage in traditional data warehouse. And I told you it requires less investment. The investment cost is very less. It is very good advantage because like you are paying for the period of time you are using the services, so the cost is less actually. But in traditional data house, it is very expensive to buy the resources and everything actually. Okay, and also it helps you to identify business trends, make future predictions with business learning, with machine learning, data science, and AI. I told you in previous also we discussed that actually to not to predict future predictions, and it is integrated with machine learning, data science, and AI. So it can be integrated with it cannot be integrated with ML and data science actually in traditional thing. It can be, but there are practical difficulties are there compared to the cloud data warehouse. In cloud data warehouse, the performance is very high, but in the traditional data warehouse, the performance is low compared to the cloud data warehouse. Auto scaling, you can see scale up and scale down in cloud data warehouse, but in traditional data warehouse, it's not available, but it is very tough actually in cloud data warehouse actually in traditional data warehouse. Okay, so in cloud data warehouse, you can build reports pulling anything you want to know from multiple data sources actually. Okay, so you can create. I told you from the beginning of the AWS Redshift, it is used for analytical purpose actually to build reports and analytical things. That's why, and it is also used to track data and performance across your organization with mixed load analysis. So it is used to track your data and performance of your data across your organization with load analysis. This is the simple comparison of cloud and traditional data warehouse actually. How the cloud data warehouse looks, how the traditional data warehouse will look like. Okay, I am moving on to the next slide. Is the slide visible, Gavaskar?
No.
Okay, something is happening actually. I think when I am moving the slide, I think
Yeah, now it is visible.
yeah. Okay. Now it is visible. Hello, Gavaskar, is it visible now? Hello.
Yes.
Yeah, sorry. Actually, I want to make it confirm. So this is the pricing which we want to discuss actually. With Amazon Redshift, you can start small at $0.25 per hour. Okay. I told you, am I right? The main difference in cloud data warehouse is pricing. Instead of if you go to the traditional data warehouse, you have to pay the resources, you have to buy the resources. Everything is very costly. Okay, that is why we are going for the advanced way. The cloud has evolved, and the AWS Redshift is in place now. So you can start small at $20.25 per hour and scale up to petabytes of data with thousands of concurrent users. Actually, this is the main advantage. Choose what is right for your business needs. Whichever your business is demanding, you can choose it with the ability to grow storage without over provisioning computer storage. So whatever is your needed for the business, you can able to provision it actually. With the provisioned AWS Rift, you can choose on-demand instances and pay for your database by the hour with no long-term commitments or upfront fees actually. So there is no long-term commit or upfront fees. You pay these things, whichever things 0.25 per hour and scale, you can petabytes of data, and you go for thousands of concurrent users actually. Okay, or choose reserved instances for additional savings. You can choose the reserved instances for additional savings. Alternatively, Amazon Redshift serverless allows you to pay for usage by automatically starting up, shutting down, and scaling capacity up or down based on your application needs. Actually, so alternately, what AWS Redshift is giving is serverless. Actually, it allows you to pay for your usage by automatically starting your instances actually and scaling up or down based on your application needs. Based on our application needs, it can scale up and scale down. This is one good advantage. So you pay only for capacity consumed while processing the workload. So this is what I am explaining from the beginning. This is a very good advantage of cloud, which is why people used to go for cloud for this advantage actually. Okay, because in Amazon Redshift it is go for serverless. It will spin up automatically, starting up and scaling down and all those things. Okay, so start at just $0.25 per hour and grow to 2 petabytes compressed actually. So you can start at $0.25 per hour and you can grow up to 2 petabytes of data actually. Okay, if you are using dense compute, which is an SSD actually, scale from 160 GB to 326 terabytes actually. Okay, in dense compute nodes, you can go that. But in dense storage nodes, in which is a HDD, you can scale from 2 terabytes to 2 petabytes actually. So this is the pricing of AWS Redshift. So pricing wise, it is very cheaper. It's very less expensive, and you can able to use the cloud services at optimized cost actually, and you can able to meet the business needs actually. This is main advantage of AWS Redshift pricing level actually. So now I move to the next slide. Is it visible?
Yes. Yes.
Right. So I want to discuss what are the similar products in the environment actually. Okay, you must have heard about different products, am I right? Alternative products for Amazon Redshift, which is there in the environment, correct? You must have heard about Azure Synapse Analytics. It is formerly known as Microsoft Azure SQL Data Warehouse actually. Okay, but it is just one data warehouse solution on the market competing with the following products. Amazon Redshift has its own advantage actually. It is very competitive. People and many enterprises are using this Amazon Redshift in the things actually. And apart from Azure Synapse Analytics, we have another thing called Snowflake. Okay, Snowflake is very much used in the market actually, and the SAP Business Warehouse and Google BigQuery. These are the competitive products which are used in the market. So, which is very used in similar to the Amazon Redshift. So, these are the similar products which is used. Okay, I move to the next slide. So, this is so almost we are coming to the conclusion of these things actually. So I will summarize the things actually from the within short time actually. Uh, the Amazon Redshift is a cloud data warehouse which is a PaaS solution actually. It is a platform as a service, and it is used mainly for analytical purpose, analytic and reporting purpose, and it can scale up to petabytes of storage. And in the architecture wise, it has the leader node, it has the compute node, it has the node slices, and it has the it will it is used. The main advantage is columnar storage, then massive parallel processing, concurrency scaling, automatic caching, backup and recovery, encryption for data at rest and data at transit, and the and cost wise, I told you the pricing, which is very effectively compared to the other cloud data warehouses actually on from traditional data warehouses, which is very expensive. It is very less expensive. So these are the main advantages. And so similar products which we have discussed is correct now, right now is Azure Synapse Analytics, Snowflake, uh, this in Google BigQuery, and SAP Business Warehouse actually. So this is what I want to present to you guys actually. It is very high level overview which I prepared for the layman terms actually. Whomever attending this seminar from non-data background can also easily understand what is the data and what is the data warehouse, how it can be used, how it is used effectively in cloud actually. So thanks, Gavaskar. And if you want to continue with the uh, demo part, actually, you can continue,
Okay.
Gavaskar.
Okay, thank you, Maheshwara Kumar. So excellent session. You have given a clear introduction about AWS Redshift and its architecture. So now it is a demo desk. So myself, I am Gavaskar S. I am from Cloud for you. We have prepared a short demo on Redshift. That is, we are going to create a Redshift cluster, and then we are going to load the data in S3 buckets, and then we are going to ingest the data to the AWS Redshift from the S3 bucket, and we are going to do some couple of SQL queries with Redshift by using the Redshift query editor. So let me share this screen. Yeah, my screen is visible. Yes. Yeah. So so this is a short demo. As I mentioned previously, we are going to load the file in S3 bucket, and we are going to create a Redshift cluster. And for creating a Redshift cluster, it will take nearly 10 to 15 minutes for creating a Redshift cluster. So already I have created a cluster I am going to show demo by using that cluster. And then after creating the Redshift cluster, I am going to create a database. I am going to create a schema and going to create a table. And in that particular table, I am going to ingest the data from the S3 bucket. And finally, I am going to query the data which is present in the particular table. by using Redshift query editor. This is a short description of the demo which I am going to show. So now let me move to AWS console. So I hope that my screen is visible. Yes. Okay. Now this is my AWS S3 console. So I am moving to bucket. So this is the bucket which I created in Mumbai region. Now you can find this is the sample data, all uses underscore pipe dot test. This is a sample data which I am going to ingest to AWS Redshift database. Now this is a data which I am going to ingest. Okay. So now moving to Redshift cluster. So now you can find Redshift cluster over here. Yes. So now, so this is the cluster which I have created. So this I will click this. So this is a cluster console. So this is a node type and this is a endpoint. So if you want to connect this cluster with the SQL client, we can connect by using this endpoint. And if you want to connect using your Java program, that is this is a Java database connectivity URL is there, open database connectivity URL is there. So you can connect the Redshift cluster by using Java program or by using .NET program. This is also done. We can do that. Well, if you want to connect by using SQL clients such as Workbench, SQL Workbench, or Teddy SQL, or some other SQL client tool, if you want to connect, you can use this endpoint. Now, these are the different performance monitoring. You can monitor the queries. What are the queries you have done? And so now properties. Network settings, you can find the permissions. So now one more thing, you have to provide IAM role over here. If you want to access the cluster, you have to provide the IAM role. Here I have set up the IAM role over here. Okay. Now moving to, now you have to we have to access this cluster. We have to go to query data. Now this is a console for accessing the cluster, that is accessing the database schema as well as table which is present in the particular cluster. So now you can expand this. You can expand this. This is a Redshift cluster which I have created. Now when you are creating the cluster, you can find this database. This database will be created by default. No? Dev database will be created by default and public schema will be there. And in that, we can find set of tables will be created by default. Okay, this is a table which is created by default. So whenever you are creating a cluster, so it will create a dev database and a public schema. In that schema, you can find the table. These are the list of tables. So now if you want to query any table, just you click this. Yeah, now you can run this. So you can get the data which is present in the particular table. Now we can see, I will show you how to run a query. No, this is a table which is present beautifully. It is present in the Redshift cluster which I created. So I have a set of queries. I have created set of queries over here. This is for selecting that, getting definition for the sales table. So just you copy this. I will copy this query and I will paste it over here. So now I can select the cluster. Now I can select the database, which database. So here is set of database is there, dev, new DB, usage. These are the databases which I have created. So now you can run the query. No? You can run the query. So you will get the description of this particular table. That's sales table. The table sales. Oh, what is the column? What is the data type of that particular column? I can get it. So now I will run the second query. So now to find the total sales on a given calendar date. So now I have to find the total sales of the given calendar date. So just I can copy this query and I can paste it over here. Now you can export this. No? You can run this query. Yeah, it's okay. No, sum is 210. So this is now we see just we are going to use the SQL queries. Order SQL queries will work in Redshift. No? So now again, I'm moving to the next query. Finding top 10 buyers by quantity. No, just you select this. Yeah, I got it. No, first name, last name, and total quantity. Now, if you want to have some insight in the chart, no, just you can do that. No, you can select some charts over here. Yeah, line chart, first name. Now you can choose the data, no quantity. This is a line chart you can get. Now, if you want to get some other bar chart, you can get the bar chart over here. You can change this horizontal or vertical. So now again, if you want some pie chart, first name, quantity. I think pie chart, no, it will not come, no, some other value should be there. Histogram, yeah, histogram it is coming. So now you can get some insight, no, that's not in a pictorial format, no, you can get some insight of this particular data which you have selected. Okay. So now we can see how to ingest the data from the S3 bucket. Okay. So what I am going to do is I am going to create a database first. Okay. Now I will tell the database as a new user. So the database name is new user, and I am going to associate the AWS user database. Okay. So now I am going to create a database. Yes, now it is ready. New database. I have created a new database. So now what I am going to do is I am going to create a new schema. Okay, new schema. Now the database, you have to choose the database, a new user. This is the database you have to choose, and you can create a schema. User list. Yes, now we can create a schema. Yes, it's ready. User schema is created. Now what I can do is I have to create a table. Okay, so now just you open a new editor. No? You can open a new editor. Yes. So now I am going to create a table. Yes. Create table uses. So this is a query for creating a table. So now what I am going to do is I am going to ingest the data from the particular test file which I mentioned in the S3 bucket. So this is the definition for creating the table or SQL query for creating the table. So now I will run this. So I have to select where to create. No, I have to select the cluster. I have to select the database. So now I have to run this. Yeah, now it is done. Yes. So now you can find one table is created. So now if you want, you can find the table, no field, user ID, username, first name, city, state. Okay. So now I have created a table. So now what I had to do, I had to ingest the data from S3 bucket to this particular table which is created. So how to ingest the data? It's very simple. Again, we can do it graphically. No, using graphical user interface, we can do that. So now just we click load data from S3. So you can browse. You can get the bucket. You can associate the bucket where the data resides. So now this is the data. Now you can choose. Now you see you have to select the cluster. You have to select the database. No, new user. Now you have to select the schema. So it's public schema, and you see user. You have to select the table. To which table you are going to ingest the data. Okay. So now by default, no, you have to choose the IAM row. Now you can load the data. Now see, you're getting some error. Okay. So now what we have to do is, so we have to create a new editor, and we can use some code. No, this is a code we have to use for ingesting the data. Okay, ingesting the data, we have to use this code. copy uses from where you are going to know from S3. Okay, this is the bucket location. You have to provide the bucket location. That is the file location, the bucket. So S3 covers -business -data all user underscore pipe dot test. Now the region name you have to provide. This is the region name you have to provide. So now again you see you have to select the cluster and you have to select the database and you have to click run. Yeah, it is done. Okay, the data is yeah. We have to select the data, refresh. Yeah. Yeah, it's done now. Now data is ingested from the S3 bucket. So it's very simple. Just know you have to know some SQL queries, and by graphically, you can do the ingestion from the S3 bucket. Okay, so that's a short demo on how to work with AWS Redshift. So just you have to remember to create. You have to create a database, and then you have to create a schema in the database, and you have to create a table. You have to create a table in the database or in the schema. And then you have to load the data. You can load the data from S3 or from the local file. So local file, the problem is you cannot upload the data file with size greater than 5 MB. It's not possible. So normally we use S3 for data lake storage. So we can load the data from S3 bucket, and we have to provide the cluster, then database, then schema, and the table you have to provide, and directly you can upload over here. Okay, so you see here again, you cannot use this default, when you are uploading. Default, this coding will be created. We cannot use this. The reason is, this is for CSV file. You see, format as CSV. So I am going to upload from the test file. Yes, yeah, I am going to upload from the test file. So the delimiter is what? The horizontal bar I am going to use. So I have to use this code for that. That's a short introduction about AWS Redshift and AWS Redshift query editor. So that's a start demo from my desk. Let me stop sharing. And if you any doubts, participants, you can ask. So you are in unmute. Participants, you can unmute yourself and you can ask the doubts with Mageshwara Kumar. Yeah.
Yeah, just want to
Yeah.
know how the compute and storage are where exactly actually. Both the compute and storage are stored in the same place or it's in a different place.
Mageshwara Kumar, hello.
The compute nodes actually, it is a leader node is a different node actually. Okay, so the compute is like I told you, am I right? If you want to use for compute operations, we have to use dense compute. Okay, if you want to use for storage, then you have to use dense storage actually, DS and DC, which I explained to you in the slide, am I right? So this is whichever is your practical scenario you want to use, you can select as per your scenario, and then you can use either dense storage or dense compute.
Okay, thank you.
Okay, Mageshwara Kumar, one more question from the chat. Can we store the transformed data from query editor to DWH, data warehouse, in another schema?
Let me see
Yeah.
the chat.
Yeah, it is possible, I think, no?
No, I'm not seeing the chat actually. Let me see the chat.
Yes.
Yeah. The question is, can we store the transformed data from the query editor to the data warehouse in another schema? Actually, yeah. If you have connections to the another schema, you can able to transfer the data from the query editor. Actually, yeah.
Participants, any more doubts? So I think we can move to the certification test. Let me share the secret code. Yeah, participants, as a part of our community, we are going to provide a level 1 certificate for all the participants. Hope that my screen is visible. So I have shared the link. I have shared the link to download the certificate. So just you can go through that link, and you can register for this particular. But register your name with your name and email ID. You can register, and you can provide the certificate code. Now already I have shared the code in the chart. The code is the secret code, or the speaker code is 31SJ78. So once again, I will repeat that the speaker code or the secret code for downloading the certificate is 31SJ78. So, so I just, again, I will share this in the chart. So if you have any issues in downloading the certificate, you can reach us in Telegram channel, that is telegram.im/multicloud for you. Okay, that's all from the certificate desk. So Mageshwara Kumar, one more question. We got one more question from the chat. Hello? Hello?
So yeah, I see the question. Can we connect Redshift with any other ETL tool? Actually, yeah, Redshift can be integrated with any other ETL tool. Yeah, it's possible actually. For example, if you are using Informatica, actually, okay, if you go for that IACS tool, whichever tool actually, it is in cloud also, which is another ETL tool, they will provide you the connectors actually. So in the connectors itself, you can able to see what are the different types of connectors which are available. So you can able to choose the Redshift. Yes, it is possible. Yeah, we can connect.
So participants, any more doubts? So I hope you can download the certificate, and if you are facing any issues, you can just share that in telegram.im/multicloud for you Telegram channel.
Any doubts, guys? It's already over.
I think we can wind up the session. Yes?
Yeah, thank you, Gavaskar, for the opportunity.
Okay.
Thank you.
Yeah, thank you. So again, thank you participants. We like to thank our mentor, Mageshwara Kumar, for giving a good session on AWS Redshift high-level overview. Once again, on behalf of Multicloud for you, with the IR, we like to thank you. Thank you.
Yeah, thank you all.